Today, we're going to talk about the basic MATLAB programming. At the end of these modules, you'll be able to write an assignment statement to define a variable and assign the value to the variable. Use the valid variable name acceptable in MATLAB. Explain the various data type and typecasting process. Also, explain the various operators including the numeric, logical, and relational operators and compose the expression using these operators and variable to compute the value. Evaluate the expression having the multiple operators following to the operator precedence in MATLAB. So you can use the basic math built-in function such as a round, sign, the absolute value. Finally, you can understand the concept of the random number generators and generate the numbers, random number, using built-in function. Okay, the variable is just a storage. Variable is a storage that you can store the single or multiple values. The way to store a value is to use this assignment statement. Okay, the syntax of the assignment statement is variable name equals sign and expression. This expression is to generate or compute the value to assign the value to the variable. Here, the equal sign is a never and never meant to be equality. This is not checking the equality. This is just to assign this expression. It's not expression, it's a value from the expression to the variable. Okay, not meant to equality. Okay, you can consider it this assignment is the value on the right hand side to the variable on the left hand side. Okay, so I'm telling that more than 10% of the students still make a mistake and still don't understand this assignment statement at the end of this course because they're confused with the equality and then this assignment statement. Equality is this one. Okay, I will cover this topic later. So always in this assignment statement, variable is placed on the left hand side here. Okay, and then expression, all other expression that generate the value placed on the right hand side. This is the example of the simple MATLAB script. What it means is the 3 value assigned to the A1 variable, the variable named as A1, 5 assigned to the A2. Okay, here this percentage sign is to put the comment on your script, which means that this is not a programming script to be executed. Okay, this is just a comment line that completely ignores when the script is executed. So basically, you can take any memo that can help to understand your script. Okay, so here when we execute this script, so you'll see this variable and then value in the workspace. Okay, I already mentioned in the previous lecture, this is the script window. This is the workspace. Okay. Okay. Here's the naming convention of the variable. All name must begin with a letter of the alphabet. Okay. Only letters, digit, and underscores are allowed. This is the only symbol that you can use in the variable names. Okay. These underscores help to define the mnemonic name. Okay. So for instance, let's say it's a task 1 variable 1 like this. Okay. This is a much more mnemonic than the task 1 like this, right? These underscores help to to separate some kind of keyword in your variable name. Okay. Do not put the empty space in the variable name. Okay, don't put any empty space. Okay, MATLAB is case sensitive. Okay, so for example, the variable. So this is the variable name, and then capital letter V. Those two variables are totally different. Okay, they're different variable, I'll say. The name should be the mnemonic. I mean, name should be some kind of the meaning. Okay, so that other people can roughly guess what the variable is from its name. That is the good, the variable name, I'll say. Okay, the clear is a function to clear out the variable and also function. Okay, you'll see how I used this clear function. Okay, this is the valid and invalid variable name. Okay, what about this one? Adder y can start with non-alphabet characters, right? Non-alphabet letter, I'll say. So wrong. What about this one? Adder non-alphabet. Okay, this one no adder. Okay, start with the alphabet, and they only use the underscore symbol, right? What about this one? Adder y due to this one, right? This symbol is not underscore. This one is the same as well. Adder. Okay. So following variable name do not produce adder, but the name should be the mnemonic. Okay. Select this one. And the love AAAA3. I mean I saw this kind of the variable name so many times. Okay. Don't use the meaningless variable name. So your variable name, this should be the mnemonic, but don't write a variable name like a Tom, Helen, like this. If you watch the tutorial video that I recorded, you'll see that what kind of the variable name that I'm using. Okay, that is the one of a good example that you can follow. Okay, here the semicolon is to use the not printing the value in the variable in the command window. The assignment statement without the semicolon at the end of the line always print the value of the variable in the command window. Okay, so unless you want to see the value inside of the variable, please put this semicolon at the end of each lines of your code. Okay, this is the one of a good practice. You can always check the value of the variable through the workspace, not on the command window. Here's a quick question. If you run script, so what is the value inside of the variable named GA1? The answer is nothing. Why? The variable names are case sensitive. That's why the GA1 and the GA1s are different variable. Okay? Okay, this is the question in the midterm exam in 2019. Which of the following script produced errors? First one, no error, right? You can start with this capital letter of your variable name. What about the second one? Error, because this is the non-alphabet letter. Error, right? This is not allowed putting the symbol except for the underscore. This one is as well. Okay. First one, this is fine, right? Variable name equal to, these are the expression for computing value. Okay. So here in the first case, this is the expression, right? Value times 2. Okay, but so don't put this expression on the left hand side. You need to always put this expression on the right hand side. Make sense? That's why answer is this one. Variables do not exist unless we define them. However, there are some variables that are already defined in MATLAB. They are called the constant. The value in these constant variables are predefined. The examples are in MATLAB are pi. This is the pi, or the I and j is an imaginary number. And then I and f is infinity. It's an infinite number. Okay? And an stands for not a number. For instance, 0 divided by 0. Okay? Okay. However, constant also the variable. Okay? So you can override the value to this constant. I don't know why in MATLAB, but constant is also a variable, so you can override the value on the constant. What it means is pi equal to 3 on your script. These are no error. Okay? Then you cannot use this pi value that predefined in the MATLAB. Pi inside of the pi is a 3. Now, after execute this line. But I do not recommend the use of the constant as a variable. Okay? Don't write this kind of the script. Okay? That's why, so I and j's are common iterator variable in the loop statement in most the programming language, Python and C, C++. I and j's are common iterators. However, MATLAB I is already used as a constant, okay, as an imaginary number. Okay, that's why if you see if you see how I write the loop statement, I used II or JJ as iterator. Okay, you'll see the many of those example in the later the slide, but I recommend use II and JJ as an iterator. Okay. Okay, so you can modify the value in the variable. Here's, although you assign the 10 to the my variable in the beginning, you can modify this value For instance, here my value plus 3. If you place in this example, if you place a variable on the right hand side of the assignment statement, it means that we are going to read and use the value inside of the corresponding variable. For instance, in this example, we put the my variable here. This means you're going to do the 10 plus 3. Okay, so we are going to read the value inside of this variable and then plus 3. That's why at the end, 13 is assigned to the my variable. Make sense? Okay, second one is you can define as many variable as possible. You can define the two variable, my variable and value, and then you can do this computation. What it means is you can read the value, my variable, and then value of this val, and then this one is the same with this one. Make sense? Again, these are expression. Okay, expression part in the assignment statement to compute the value, and then equal sign here indicate that value from the expression is assigned to this variable. Okay, please don't be confused. Okay, this equal sign is used in the assignment statement. Okay. Finally, this example of the how to swap the value between two variables. You you assign the 10 and 5 to this variable, each variable here. But what happens if we run this script? Okay. If you run this, okay, at this time, this, do not consider this a script, and then you define the two variable and then run this script. What happened? Okay, so my variable 2, that is a 5, right? 5 is assigned to the my variable 1. Okay, in this stage, my variable 1 become a 5, my variable 2, so 5. Okay, then my variable 1 is assigned to my variable 2. 5 assigned to 5, or the 5 assigned to my variable 2. That's why at the end is a 5 and 5. Okay, this is not a script to swapping the value. The reason why this is not swapping the value is you overwrite the my value to the my value 1. So my value, original my value 1 is disappears, right? That's why you cannot assign this value to the my value 2. So that's why the way of the swapping the value is you define this another variable and then assign to this my variable 1 value in the my variable 1, and then your my variable 2 value to the my variable 1, and then my value 1 is already overwritten. That's why this temporary this value in the TMP is placed here. So you assign the original value to the my variable 2, and then at the end you get this result. Okay, the values are swapped. Make sense? Here's the question. The fundamental question is why we swap the value using this script. Okay, we can just simply my value 1 equal to 5, my value. Okay. You can just simply write this screen without, the making this code. Okay. In this case, we already knew what value inside of this two variable. Okay. In that case, this is working. However, if your code is getting longer and longer, the value of my variable 1 and 2 are computed from the prior process. It's not just a numeric values assignment here. And then you cannot manually, assign the value like this. Okay? You have to use the script like this. Make sense? Every expression and variable have associated types or the classes. Humans don't pay much attention to the size of the number. Okay? But the computer must do because it has to allocate the memory to hold the number. Thus, the type is important. I would say the type or class is considered as a container. Okay? If you define the integer value, no decimal point, you do not use the huge bin to contain this number. If you are dealing with the large number with a large decimal point, you need to have a bigger bins to represent individual value, okay, in your computer. Okay, logical type is contain only the yes or no, as like a true or false. So it doesn't have to using this larger bin. So logical types contain only the yes or no. I would say true or false. Here, true, false, constant. Okay, true represent the logical one, and false represent the logical 0. Okay, what it means is false is like a 0, but this value is a logical type. Okay, these logical types contain only the two values. 0 is like a true or false. Okay? Another type is the character that contain the single letter or the symbol. Okay, how to define that? You can put the single quote. String is to define the set of the character, select a text. Okay, you should use the double quote, define it. Okay, we will cover in the module 11. The MATLAB's default type to represent the number is a double. Okay, double is the biggest size, biggest data type. That's why you don't have to risk of the numeric error or overflow. Okay, for instance, let's say you can putting any number, any numeric number here, double. Okay, for integers and all types of the numbers you can putting in the double type. Okay, but it's not possible the other way. For instance, you can put the double number in the integer bin. Okay, in that case, you have to round off or some kind of the risk of the overflow. Okay, but MATLAB is the default type is the double. Okay, so you don't have any risk of the numeric errors or overflow, but the drawback is they're using this larger bin, so we need to have a larger storage and then slow processing speed. Okay, here's the simple experiment. Class is a function that can determine a class of the variable or value. Okay. For instance, a class and then putting any value or the variable here, they can show the data type. If you put here, that is a string, right? They printing out the string here. If you put this one, that is a character, right? True, I mentioned that true is the constant. Inside is a logical 1. That's why this is logical type. This then is the double. What about this one? That is a double. I mentioned that 10 and 11 is integer, but default type is the double. So whenever you define any the number, you put the number on the variable, all these variable is the double type. Okay, for instance, val 1 is a 10, and then you put the val 1 here. The outcome is the double, not the integer. Make sense? Okay, so this is one of the confusing topics in this module. There are many functions that convert the value from one type to another. The name of this function are the same as the name of the type. The name can be used as a function to convert a value to that type. That is called the typecasting. For example, here A include the logical 1. The logical is the class type, right? And then parenthesis, this is how you use the function, and then put a value. What is the 1 here? Double. As I mentioned before, all the numeric value, the default type is the double, right? So this script is basically typecasting. 1 is a double, the logical is the class type, as well as this is a function to convert the double type, the numeric type, to the logical type. That's why it becomes a logical here. So double A is a logical, and then double is a function to convert the value to the double type. That's why B is a double type. Okay, this is the explicit way of converting type. Okay. On the other hand, let's see the second example. A is a logical 1. What if we add 2? 2 is the double, right? A is the logical. What happened? Okay. In this case, the types of the value is implicitly change it to the double. For instance, A is contained 1 or 0. Okay, and then plus is operator. You're adding the logical value and the double, and then this is implicitly changed to the larger container. In this case, is double to perform this operation. That's why A is implicitly converted to the double type. So 1 logical 1 become a double 1. That's why B become a 3. The type is the double. Make sense? B contained the 3. What happened? We are converting to the B to the logical type. The problem of the logical type is only carries 0 or 1. That's why in this case, non-zero double or the non-zero numeric type value become a 1. otherwise 0. Okay, for instance, a logical any number except for 0 become a logical 1, true. Okay, otherwise 0. So only this one logical, you put the 0 here, that is false. Okay, this is a very important concept for the logical operation. Okay, so logical, put the number, depending on the number, it convert it to the true or false. Okay, basically in this slide you should remember this implicit typecasting. Sometimes it is very useful to computing the value. We'll learn the typecasting for the character value in the next module. Make sense? Okay, good. Here's a short example about the typecasting for logical or double type. Okay, what the value is assigned to each variable from A to K, and then place gets their types. Okay, basically in the workspace you can check the class or the type as well, but in this case here I'm asking you the types of the variables. I make another column here. Okay, A double, right? Because the double is a default type. B logical, right? So explicit typecasting, right? C and D, all these are the logical value. Okay, A is a double, B, C, D is the logical, right? But A is a 3, I will say except for all value except for 0 producing the true logical 1, right? This one, get up to this point. What about the E? Okay, A is the 3, 1. So this is just a simple numeric addition, right? So E become a 4, double. 1 double B. Okay, so this is the confusing part. What happened this one? This one become a 2. Why? B, you already converting the numeric value to the logical value. So B, inside of the B, there's the logical 1. So if you convert the logical 1 to double, that become a 1, not 3. Okay, so that's why this become a 2. Make sense? G is the similar to G is simply 2, right? What about this one? Okay, so in this case you can, so logical, what it means in this expression is to say like what is the typecasting of this value 3 minus A? 3 minus A comma 0, so logical 0, like this. Okay. Okay, the final example is B minus C. B is the logical 1. C is the logical 1. What is this one? 0. Why? Basically, you cannot do the addition or subtraction between the two logical value. Okay, this minus is like a numeric operator, right? That's why B and C are implicitly typecasting to the double. So B become a 1, C become a 1. That's why 1 minus 1 become a 0. Okay, that's why K become a double type, not logical type. Although we do the operation between the logical type variable. Make sense? Okay, this is the same with the K equal to double B minus double C. Okay, make sense? Okay, good. Operators are symbol to compute value. There are two types of the operator: unary operator, which operate on the single value, binary operator, which operate the two value. Okay, simply minus 3 is this one is the unary operator. Okay, that perform minus times 3, right? This is a unary operator because only the one single number is involved in this operation. Okay. Okay, the other operator is the plus, minus, times, division, and exponentiation. Okay, so this is similar to the math equation. 5 plus 1, 6, 10 times 2, 20, 10 to the power of the 2 is 100, 100 divided by 5. Yeah, this is like a numeric operation that we are familiar with. Okay. Okay, like this one, you can put as many operators as you can in this expression part to compute the value. Okay. Okay. Some operators have a precedence over the others. Okay. This is very similar to the mathematical symbol precedence order. Here's the precedence order. So you can clearly get this if you see this example like this. What is this value? 12, right? Why? Parenthesis is a higher precedence. That's why we do the computation by plus 1 first and then times 2 later. That's why it's 12. Okay. What about this one? Exponentiation is the higher precedence order, so that's why this is the 100 times the 3 become 100, right? In this case, we do this one first and then do the exponentiation. That's why 10 power of 5. Okay, that's easy, right? What about this one? Is it 100 or minus 100? Exponentiation is a higher precedence order. That's why we do this one first and then do the unary operator. So minus. That's why it's minus 100. Okay. In this case, rather than relying on this precedence order, it would be better to clearly define this operation using the parentheses like this or like this. Okay, this is the good practice. Okay. All right. Here's the example. This one, 6 plus 3 minus 6. That's why 3. Okay. Since this exponentiation is a higher precedence order, that's why 10,000 times 3 minus this. Okay. You can easily do the rest of the operation. Okay. Does it make sense? Okay. Good. Before moving forward, I'd like to point out the one thing. There are operators that we are familiar with. It's like a plus, a minus, the division. It's easy. Okay, why? Because the syntax where operator used in this script is almost the same as the one in the math equation. Okay? I will introduce this other operator in the following slide that you are not familiar with. Okay? But remember that the way of the using those operator is exactly same as the way used in this familiar with operator. Okay? Fundamentally, all operators are to compute the value from the associated one or two value. Okay? Although you see the non-familiar with operators, don't panic. Okay?